Alright, testing. Okay. Section 2, Welding, Bracing, Ferrous Metals. 1113, Welding, Sheet Metal. For welding purposes, the term sheet metal is referred to thickness of metal that up to, including 1/8 of an inch. Welding sheet metal that up to 1/16 of an inch can be made satisfactory by flanging edges at the joint. The flanges must be equal to the thickness of the flange. The edges should be aligned with the flanges tacked with the weld at every 5 to 6 inches. Heavy angles or bars should be clamped on each side of it to prevent joint distortion and buckling. This raises the edge of the equally melted by welding failures. Produce the weld nearly flush of the sheet metal. Serve with the control of the welding speed of the flame motion. Good fusion underside of the sheet can be obtained, but without burning through. The planes square butt joints can also be made with the sheet metal to 1/16 of an inch by using rust-resistant copper-coated low-carbon filler rod in diameter. The method of lining the joint and tacking the edges is the same as used in the welded flange edge joints. When it is necessary to make an inside edge of the corner weld, there is a damage of the burning through the sheet unless the special care is taken to control of the welding heat. Such welds may be satisfactory sheet metal up to 1/16 of an inch thick by following procedure below. Heat the end of 1/8 of an inch low carbon welding rod until approximately 1/2 inch of the rod is molten. Hold the rod and so that the molten rod end of the above the joint until it be welded. By sweeping the flame of the graph of the molten end of the rod, the melting can be removed with the deposit. Assuming the quality of the molten welded metal relatively large and compared with a light gauge sheet, its heat is sufficient to preheat the sheet metal with the passing of the flame quickly back and forth. The filler metal with the distributed along the joint. Additional heat is supplied with the flame to produce the complete fusion. The method of welding can be used, making the difficult repairs of automotive bodies, metal containers, and similar applications. Consider whether it should be given an expansion contraction sheet metal before welding is started. Um, for sheet metal, the 1/16 of an inch, 1/8 of an inch thick of the butt joint with a space approximately 1/8 of an inch between the edge should be repaired, and a 1/8 of an inch diameter copper coated low carbon filler rod should be used. The sheet metal welding on the filler rod butt joint should be done with a forehand method of the welding. Generally, the term should be applied with many of the ferrous metals, which are differently greatly in both over the chemical and physical properties. In general, they must be divided into plane and alloy groups. The following proper procedure: the most steels be successfully welded. However, the parts fabricated with the welding generally consist of less than 0.3% of the carbon in the heat. This heat is increased with the carbon combining the power of the steel. Care must be taken during all welding process to avoid carbon. Welding process: sheet heated with the steel heated with the oxyacetylene flame becomes fluid with between 2450 to 2750 degrees Fahrenheit. Depending on the composition of the passes through the soft range of the trim and the solid with the liquid state with the soft ranges. Enable for the operator to control the weld to produce the weld with a good fusion of the welding rod. Should not be played with the molten metal with the rod base of the metal, but they should be melted together so they will solidify their form. A solid joint care should be taken to avoid heating a large portion of the joint. This will dissipate with the heat with the main cover. Some of the welded metal will adhere but not fuse with the both sides of the welded joint. Flare should be directed again for the side of the bottom of the welded joint. This will allow the penetration of the lower section of the joint. Welded metal should be added in sufficient quantities to fill the joint without leaving any undercut overlap. Do not overheat. Overheating will burn the weld of the metal to weaken the finished joint. Impurities: oxygen, carbon, nitrogen impurities to produce the defective weld metal because of the tendency of the increased porosity, blowholes, oxide, slag inclusions. Or when oxygen combined with the steel with the forming iron oxide with a high temperature carrier should be taken in to ensure the oxide form and are removed, and then proper manipulation of the rod and torque flame. Oxidizing flame causes the steel flame with a given off stroke with the oxidizing form to distributed through the metal with a create cause brittle porous weld with the oxidizing form of the surface of the furnace weld that may be removed with the wire for burnishing after cooling. Carbonizing flame: add carbon to the molten steel with the causing of the boiling of the metal. Steel welds made with these strong carbonizing flames are hard and brittle. The nitrogen atmosphere will combine with the molten steel to form, and the nitrides of the iron will impair with the strength of the ductility, including with sufficient quantities. Control melting rate with the base metal weld rod with the side of the puddle. Special speed welding, flame adjusting, and inclusion of the impurities with above the source of may be held with a minimum. Welding steel plates. In plates of the 3/16 of an inch with the end thickness joints are prepared with a space for the edge of the equal to the plate difference to allow for the flame of the welding rod penetrating the root of the joint. With the prepare allowance should be made with expansion contraction in order to eliminate warping the plate with the cracking of the weld. Edge of the heavy section steel plates of more than 1/3/16 of an inch thick should be leveled to obtain the full penetration of the welded metal with a good fusion of the joint using forehand method of welding. The plate 1/2 to 3/4 inch thick should be prepared with a huge height joint of all cases of the root faces to provide supply of the base to the joint within cushion for a speed layer of the welded metal with the backhand, generally with the use of welding these plates. Note, welding plates 1/2 inch to 3/4 inch thick is not recommended for the oxy-settling welding. Edges plates of a 3/4 inch thick are usually prepared by a double V groove with a double U type when welding can be done with both sides of the plate. Single V or single U is used for all plates thickness when the welding is done with one side of the plate. Alright, general principles of welding steel. All welded balanced natural fluent flame. A well-balanced neutral flame is used for welding most steels. To be sure that the flame is oxidizing, sometimes use the slightly oxy-settling feather. The very slight excessive acetylene may be used with the welding alloys with a high carbon chromium nickel content. However, increased welding speeds are possible using slightly reducing flame to avoid excessive gas pressure because if it gives the harsh flame often result with cold shuts and laps makes the molten metal control difficult. Tip size and volume of the flame should be sufficient to produce the metal with the full molten state to produce complete joint penetration. Care should be taken to avoid the formation of the molten metal drip heads from the bottom of the joint. Flame should bring the joint edge of the fusion point ahead of the puddle of the weld to progress. The pool of the molten metal should progressively even down the seam of the weld is being made. The inner cone of the flame should not be permitted in the cone contact with the welding rod and molten metal or the base metal of the flame should be manipulated with the sort of the molten metal is protected with the atmosphere of the envelope of the outer flame. The end of the welding rod should be melted with the place in the puddle under the protection enveloping flame. The rod should not be melted above the puddle allowed to drip into it. Alright, brazing. General. Brazing is a group of the welding process produced for the coolancy of the material for the heating of a suitable temperature using a filler metal with having liquidus above 840 degrees Fahrenheit. Below the sleeves of the base metal, the filler metal is distributed between the closely fitted with the surface of the joint capillary attraction. Brazing is distinguished from soldering, and the soldering employs a filler metal having a liquidus below 840 degrees. When brazing silver alloy filler metal to silver soldering, the alloys are liquidus temperatures above 840 degrees Fahrenheit. Brazing must meet each of the three criteria. The parts must be joined without melting the base metal. Filler metals must have the liquidus temperature above 840 degrees. And C, the filler metal must wet the base metal surface of the drawn onto with it held in the joint and capillary attraction. Alright, 4. Brazing is not the same as brazed welding, which is used the brazed filler metal with the balance of the deposit filler for the grooves exactly at the points that it is to be used. Brazing filler metal is also distributed with the capillary action limited to the base metal fusion may occur with the brazed welding. To achieve the good joint using as various brazing process, the parts of it must be cleaned with the protective of either the flux atmospheric during the preheating of the preventing excessive oxidation. The part provides capillary from the filler metal with the properly aligned with the heating of the process must be selected that they provide with the proper brazing temperatures and heat distribution. Principle. Capillary flow with the most important principle to ensure the good brazement with the provide with both the joining of the surface molten metal filler metal with the joint with the most also properly spaced and to permit efficient effective capillary action. Result of the coolancy more specifically capillary is result of the surface tension between the base metal with the filler metal the flux atmosphere with the contact angle between the base and the filler metals actually practice in brazing filler metal flow with the characteristic also influenced by consideration involved with the fluidity, viscosity, vapor pressure, gravity, and the effects of the metallurgic reaction between the filler metal and the base metal. The brazed joint within general with one of a relatively large area with a very small thickness with a simple application process of the surface of the joint to clean with the remove the contaminants of the oxide next to the coated with the flux of the material capable of dissolving solid metal oxide present with the preventing of the new oxidization. Joint area is then heated until the flux melts and cleans the base metal with the protected against the other further flux and liquidization fluid fluxing layer. Brazing the filler metal is at some point with the surface of the joint area with the capillary action must be higher between the base and the filler metal than thus between the base and the flux. Therefore the flux is removed from the filler metal with the joint upon the cooling of the room temperature will be filled with the solid filler metal with the solid flux will be found with the joint face. Surface. High fluidity is a desirable characteristic of the brazing filler metal between the capillary action but must be insufficient to cause the viscous filler metal to run into the tight fitting joints. Alright, brazing is sometimes done with active gas as hydrogen, aiming with the inert gas volume of the atmosphere, brazing element for necessity of the post cleaning, and ensure the absence of the corrosive metal, mineral flux residue of the carbon steel of the stainless steel of the superalloy component. Ones are widely processed atmosphere reactive with the gas of dry hydrogen, dissociated ammonia, argon, vacuum. Large vacuum furnaces are used for the brazed zirconium, titanium, stainless steel, and factory metals. With good processing procedure, aluminum alloy can also be vacuum furnace of the braze with an excellent result. Brazing of the process performed for the making the strength of the metallurgic bronze with the preserve of the beneath the base metal with the property of the economical process of the general brazing process specified with according to the heating and the method of the industrial significant. Whether the process used with the filler metal with the melting point with the 840 degrees Fahrenheit but below with the base metal with the distributed in the joint capillary action of the brazing process. Torch brazing, furnace brazing, induction brazing, resistant brazing, dip brazing, infrared brazing, torch brazing. Alright, torch brazing is performed by heating the gas torch with the proper side to the tip of the side of the filler metal with required with the composition and appropriate flux that depends on the temperature of the amount, the heat amount required with the fuel, gas, acetylene, propane, city gas, etc. may be burned with air, compressed air, and oxygen. Brazing filters may be replaced with the joint with the forms of the ring washers, strips, and slugs and powder, or it may be fed with the handheld filler metal wire with a rod form. In most cases, in any case, the proper cleaning of the fluxes are essential. For manual torch brazing, they may be equipped with a single type of either single or multiple flame. The manual torch brazing is particularly useful on assemblies involving section unequal mass welding machines. Operation can be set up with the production rates allow using only one and several torches equipped with a single or multiple flame tip of the machine with the design to move with either work or torches or both. Remixed city gas, air, flames, and refractory type burner is reused. Alright, your furnace brazing. Furnace brazing usually extensive where the part of the braze can be assembled with the brazing filler metal with the form of the wire with the foil filling, slugs, powder paste, tape, and replace the near with the joint of the process, particularly with the apple with the high production brazing with the flexing employed with the except within an atmosphere is specifically introduced the furnace to perform the same function. Most of the high production brazing is done with reducing gas atmosphere such as the hydrogen combustible gas and exothermic form with the evolution, endothermic form with the heat absorption, pure with the in air such as the argon helium are used to obtain special atmospheric properties. B. A large volume of the furnace brazing performed with a vacuum with to prevent oxidization of other and eliminate the need of flux. Vacuum brazing is widely used in the aerospace, the nuclear field, with the reactive metal with the joint, whether they are entrapped in fluxes, whether it be intolerable to vacuum, they maintain with the continuous pumping and remove the volatile consistent C's liberated during brazing. They are some of the base metal of the filler metal, but they should not be brazed in the vacuum because low boiling point, high vapor pressure can institute the main law for the types of the furnace generally with either batch. For the continuous, the first furnace are usually heated with the electrical resistant elements for the gas and oil should have the automatic time and temperature controls cooling in the system and accomplished for the cooling chamber. The wares are placed over the hot retort and other integral ports of the furnace design. Forced atmospheric injection, any other method of the cooling parts may be placed in the furnace singly, and batches are continuously conveyor. Our vacuum is a relatively economic method of providing accurate with a controlled brazing atmosphere. The vacuum provides sufficient cleanliness, neither a good wetting follow with filler metals without the use of the flux of the base metal with the containing chromium silicon can easily be vacuum brazed with a very pure, low dew point atmosphere as would otherwise required. Induction brazing is a process with a heat process of the brazed metal is obtained with a high frequency electrical current with the consist of the motor generated with the resonance spark with the graph of the vacuum tube oscillated with the induced with the produced with the magnetic electrical contact with the parts or metal. The parts are placed within the ear of the water coil carrying out an alternating current that do not perform any of the electrical circuit of the brazed filler metal normally is pre-placed. Careful to design with the joint with the coil set up with the necessary to ensure that the surface of all the metal of the joint with the brazing with the temperature for the same time the flux is employed with the atmosphere specifically induced with the perform the same function. The equipment that consists of the tongues and clamp for the electrode attached for the end of each for the arm. The tongues should preferably be water cooled to avoid overheating the arms of carrying conductors attached by leads of the transformer. Direct currents may be used with comparatively expensive resistant welding machines are also used. Electrodes may be carbon, graphite, refractory metal, and copper is according to the required conductivity. Resistant brazing heat necessary for the resistant brazing of the resistance to the flow of the electrical current of the electrodes when the joint of the braid of the parts can compromise the joint form of the part of the electrical circuit with the brazing filler metal with some of the convenient form is pre-placed with a face fab with this fixing is done with the due potential for the conductivity of the fluxes. Most fluxes are insulators when drive of the flux is employed when the atmosphere specifically introduced to perform the same function. The parts to be braved that are held between two electrodes, proper pressure for the current are applied, but the pressure should be maintained until the joint is solidified. In some cases, both electrodes may be located within the same side of the joint with a suitable backing to maintain required pressure. Alright, moving on to 6, dip brazing. There are two methods of dip brazing: chemical bath dip brazing, and the molten metal dip bath bathing. Chemical bath dip brazing with brazing filler metal with a suitable with a pre-placed assembly immersed with a molten bath of molten salt. Salt bath furnishes the heat necessary for the brazing, usually provided necessary with the protection from the oxidation. If not, suitable fluxes should be used. The salt bath will contain the metal with the other suitable pot, but they also cover the furnace, which if the heat from the outside of the wall of the pot means with electrical resistance units placed in the bath until the amps squared over the loss over the bath itself. Molten metal bath dip brazing parts immersed in the bath of the molten brazing with the filler metal contained in the suitable pot. The parts must be clean. Flux is necessary. Copy over the flux should be maintained over the molten bath to protect them from oxidation. Method largely from fine with the brazing small. Parts such as wires, narrow strips of metal with the end of wires and part must be held firmly together. They are removed in the bath until the brazing filler metal is fully solidified. Alright, 7. Infrared brazing. Infrared heat, the radiating heat obtained below the red rays of the spectrum of the wind, while every black source of the same visible light with the principle of the hitting of the dome of the invisible radiation. The heat source of the lamps capable of delivering up to 5,000 watts. Radiant energy of the commercial available to labs do not necessarily need to follow the contour part of the heat with enough to heat input versus and inversely square with the distance of the source of the reflectives of the UV to concentrate the heat. Assemblies to be brave, they have support with the position of the assembly with the energy of the impingement over the part. Some of the application assemblies over the itself closed. However, the applications when assembles with lamps over the place in the bulge are retort, then they can be evacuated or in with the inert gas atmosphere maintained with the assembly heated with the controlled temperature of the edge indicated with the thermocouples. The part is moved with the cooling platens with the after brazing. 8. Special process. Blanket brazing is another process of the brazing. The blanket is resistant heat. Most of the heat is transferred to the parts by two methods of conduction radiation later being responsible for the majority of the heat transfer. Exothermic brazing is another special process with which if the heat required of the melt of the flow of the commercial filler metal will generate with the solid state with the exothermic chemical reaction. Exothermic chemical reaction is defined as any of the reaction between the two or more reactions in which the heat is given off due to the free energy of the system. Nature of the provided with a countless number of the reactions, however, only due to the solid state with the nearly solid state metal to metal oxide reactions are suitable for the exothermic brazing units. Exothermic brazing utilizes simplified tooling equipment. The process employed with the reaction heating and the brazing and joining of the nearby interface to a temperature when pre-placed with the brazing filler will melt and wet to the metal interface surface of the brazing filler metal can be commercially available to having suitable melting of the flow of the temperature. Only limitations may have be thickness of the metal must be heated with through the effects of the heat and the previous heat treatment of the metal of the properties. Alright, 4. Your selection of base metal. In addition with the normalized mechanical requirement of the base metal with the brazing with the effect of the brazing cycle with the base metal with the final joint strength over the must be considered cold work strength of the base metal will be to deal with the brazing process over the temperature and the time of the annealing range of the base metal being processed. Hot cold work heat resistant base metal that can also be brazed. However, the annealed physical property will be available in brazement with the brazing cycle, usually with anneal with the cold water work base metals. Metal using the brazing temperature very low with the time of the heat with the vary of the short with not practical with the cold water base metal with the brazing operation. Brazing must have the string above them and annealed property with the base metal with the brazing operation. Heat treatable base metal should be selected with the base metal with the oil quench type with the air quench type. They can be brazed with the hardened in the same separate operation. The precipitation and hardening of the type of the brazing cycle with the solution and treatment cycle may be combined. The hardened parts of the braze of the low temperature filler metal with using the short time of the temperature maintain mechanical property of the strength of the base metal with the effect of the strength of the braze joint with the space metal with the easier of the braze of the others, particularly with the special brazing property. For example, the nickel base metal with containing the high titanium aluminum addition to the present of the special problems furnishing brazing with the nickel plating. Sometimes use the barrier coating to prevent the oxidation titanium aluminum present with the breathable that wettable for the brazing filler metal. Alright, brazing filler metal. For satisfactory brazing application, the filler metals must possess the following property: the ability to form brazed joints if possible, suitable mechanical physical property within intended the surface of the application of the metal point with a melting range compatible with the base metal being joined sufficient fluidity of the brazing temperature of the flow with the distribution of the properly prepared joint of the capillary action. Composition of sufficient homogeneity, stability with the minimize of the separation institutions, the liquidation under the brazing condition, but they being encounter the ability of wet surface base metal being joined, form strong sound bound, depending on the requirements of the ability to avoid base metal with the filler metal interactions. 11:15 brazing gray cast iron. Gray cast iron can be brazed with very little or no preheat. For this is the reason the broken casting would otherwise need to be dismantled, preheated, and can be brazed in place with non-ferrous metal with such as the naval brass, 60% copper, now 39.25% zinc, and 75% tin, satisfactory for the purpose of the melting point with the non-ferrous filler metal with a level 100 degrees lower than the cast iron. Consequently, the work can be accomplished lower heat with the input with the disposition of the metal with the grade with the brazing can be accomplished faster because of the lower heat with required with the brazing thermal stress of the development and less severe with the stress relief with the heat treatment is usually not required. The preparation of large casting brazing such is much as likely required with the welding and cast iron rod. The joint with the braid with the must clean up with the part must be sufficient to warm the preventing chilling the filler metal before sufficient penetration of the binding are obtained. When possible, the joint should be braided on both sides to ensure the uniform strength throughout the weld. The heavy section edges beveled with a 69-degree V groove. And then 11:16 brazingable malleable iron casting usually repaired by the brazing becomes a heat required with the fusion weld to destroy the property of the malleable iron because of the special heat treatment required with the development of the malleability impossible with the complete with the restore the property of the simple annealing when the special heat treatment can be performed welding in the cast iron filler or reassembling of the feasible. Section 3 related processes. Testing.